When once you have tasted flight, you will forever walk the earth with your eyes turned skyward, for there you have been, and for there you will always long to return. And that's a quote by Leonardo da Vinci that I actually have on a T-shirt that I got from Embry-Riddle. It's actually one of my favorite T-shirts because I actually really do like that quote. So today I'll be explaining how aircraft actually fly, and it's quite fascinating to me. And you can talk for hours on this topic, as there's so much to it. I mean, I just took in aerodynamics class recently, and I mean, I knew it was complicated before that class, but afterwards, there's a lot more to it than I ever knew, and I would actually have liked to continue taking that class, just due to how much is involved with aircraft flight. So, to give you the basics, I'm sure a lot of you already know how planes fly. So I'll give you an overview, and to help me with this, I actually do have a model aircraft here. Okay, now this is, in case you don't know, this is an Allegiant MD-80, and I know for those of you who know a lot about planes, it kind of looks more like a DC-9, but for the purposes of this video, this is an MD-80. Anyways, to begin, I'll show you the different parts of the aircraft, going from the nose back. So we have the nose cone here, and the flight station's up here. Now, the body of the aircraft is called the fuselage, and that's where the passengers, cargo, and all the payload are held. Now, in the tail section, we have the two tail-mounted engines on the MD-80. It's more common for aircraft to have their engines mounted underneath the wing, as far as commercial jets go. Also, we have the vertical stabilizer here, and the horizontal stabilizer here. So those are the main structural components of the aircraft. Underneath, we do have the landing gear, which would come out of these doors here. There's the main gear, and the nose gear comes out here. Okay, so now, how planes fly, we've got control surfaces that allow the pilot to control where the plane actually goes. And each of those control surfaces are located on the major components that I just listed. So first, we have the ailerons, which are located on the wing, and they're on each wing, and they control the roll of the aircraft. So when this aileron is deflected down, the airplane or the wing is deflected up, and this one goes down, and we create a rolling motion for the plane. Next, we have the rudder, which controls the yawing motion of the plane. It doesn't actually steer the plane, but it controls the yawing motion. Next, we have the elevators, which control the up and down motion of the nose. And when all of this is used together, you can actually control where the plane goes. So to make a plane turn, the ailerons are deflected whichever way you want to turn. So let's say the plane banks this way. Now what happens is called adverse yaw. When this wing goes down, it actually gains speed, and when this wing goes up, it loses speed. So what happens is the plane wants to go this way. Now to counteract that, because now you're flying crooked, you don't want that. So now to counteract that, use the rudder to straighten the plane back out. So you're flying like this, rudder kicks it back out this way, and you can fly in a coordinated turn. So now the four main forces of flight on an aircraft are thrust, created by the engines, and that is opposed by drag, which is caused by air hitting the leading surfaces of the aircraft. We also have lift, which is created by the wings. And counteracting that, we have gravity that pulls this massive aircraft down. Now, when lift is greater than gravity, the plane rises. When lift is less than gravity, the plane will descend. And when lift is equal to gravity, the plane will maintain an altitude. Same goes for thrust and drag. When thrust is greater than drag, the plane will accelerate. Thrust is less than drag, the plane will decelerate. And when thrust is equal to drag, the plane will stay in a constant speed. Now, the most interesting part, and what actually makes the plane fly, is airflow over and under the wing. Now, if you look at two air particles that are just about to go over the wing, you have one that goes over, one that goes under. If they hit the wing at the same time, they have to meet up behind the wing at the same time. So now the top surface of the wing is curved, the bottom surface is more flat. So what happens is according to Bernoulli's principle, and that is a whole topic on its own, but for the purpose of this presentation, Bernoulli's principle states that when the air particle goes over the wing and travels a further distance over the curved surface, it actually has to speed up. And when it goes under the wing, it has a more direct path and flies relatively slower to the air particle above the wing. So what happens is that pressure above the wing is decreased, pressure below the wing is higher than the pressure above the wing. So now basically that just causes suction and causes the plane to rise. Low pressure on the top, high pressure on the bottom, makes the plane rise. Now there's a whole lot more to this, but I've already talked for 5 minutes, and I could keep going. But anyways, that is basically how planes fly, and it's quite fascinating to me, and I'm sure it's quite fascinating to a lot of other people too. And I have enjoyed speaking about this, and I hope you enjoyed the presentation. Thanks.